In the last segment, we discussed about two force members and three force members because they have their general applications in any multi-body systems which is in equilibrium or otherwise. And then we said that we will take it forward to analyze the plane trusses. Okay. Now, what are these trusses? Just try. Okay, let me write it here. Trusses. Okay, and in fact I should write, say, plane trusses. What it means is we are talking everything in 2 dimension, not in 3 dimension, but whatever we discuss for 2D is very easily that can be extended to 3D. Okay, so first you concentrate on 2D, then it will be very easy to extend it. Okay, now how to define or let's first understand what a truss is. Suppose you have say a bar like this. Okay, so whenever I draw something like this in this chapter, this is a representation for say a 3D thing which looks something like this, okay, and which has got, say, a two holes which have been made to put a pin through that, so that one more such bar, if you want to join, for example, suppose you, okay, now suppose you make it like that. Okay. Now that you put a pin over here and through the other bar also, and they basically join with each other, but then this pin, you think of that pin as a bearing which is free to rotate. Okay, that means this bar now can freely rotate about this point. Similarly, this green bar also can be rotated freely about this point of join. Okay, so that's the idea, and then we don't show these thicknesses of these members, and we simply draw like this. Okay, so it's actual version which will be drawn will be something like that, and this. Okay, in fact, without even this point being drawn, you should understand that such kind of a thing exists. And in fact, there is a pin joint over here. All the details we are not going to show in the picture. Only this much will be the representative diagram for this kind of a configuration. Okay, and then if now I join one more such thing, for example, say this. Okay, now this 3 members, if I join each other, though these joints are again pin joints which are free to if I remove one of the pins, they are free to move with respect to each other, but as soon as I put all the 3 pins, they are completely stuck. Now they become a structure, in fact. Okay, so whenever you have 3 member what do you call configuration like this configuration, so it becomes a structure. Okay, but more than 3 if you join, in fact one more level of schematic diagram if you want to draw it can be simply drawn like this. Let me in fact draw with different colors. So say for example this is one, say then orange, and then this purple. Now this also can be a simplified representation of what we have shown here, assuming that all these lines are representing these bars. Okay, so the first important point is that these joints are pin joints which are free. So that means you do not, or any of these bars, they do not transfer any moment, or they cannot twist the other bar which they have connected to through these joints. So that's the point. Okay, and as soon as you see this kind of 3-member configuration, they become very stable and they are rigid. Basically, when I say stable, I meant rigid. Okay, they can't move with respect to each other. Now if I join 2 more say bar like that, even like this, and say 1 more so like that, again now here you can't move anything, because this loop and this loop, both of them are like rigid bars. But if I remove now this bar from the middle, then the whole system becomes flexible and it doesn't remain even like a structure. Okay, so such things we are not considering here, because they will be discussed in the subject called mechanism. When you have certain required or unrequired movement between the members, they will come under the study of mechanism, not of structures. So we are talking about structures when everything will be frozen, everything will become a like a rigid body as soon as you fix all the joints, okay, the pin joints. And then some of these points will be connected to say for example with the ground, like this one. If I say, now we know what it means. This is again a pin joint which is connected to the ground, and maybe here I'll put another point like that, and this we know what it is. We discussed these connector types. So this is a roller support like that. So then this whole thing is now a structure on which we can actually apply forces anywhere we wish. For example, say, and forces anywhere, when I say, I mean that we are assuming actually that all the forces are actually acting on the joints and not on the bars. Okay, even if the forces are acting on the bar, we will transfer them by some means to the joints. Okay, so all the forces will be acting on the joints, and because there is no way that any of the bars can transfer any moment or the twisting effort to any other bar, so we don't consider any moments being acting there. Okay, so that is in a way defines what a truss is. Okay, and then one more point which will come out of all this configuration or the setup is that each of the members, this is very important, in fact this is the most important thing about the trusses, that each of these members are only 2 force members. Okay, so they are 2 force members, every member. This is in fact the most important fact about the truss. So how do we in fact define or the important points about the truss? There are members, there must be members like these, there must be joints, okay, like this. So members, joints, and then it should be a structure. That means relative movements must not be there between members. And then I'm just pointing out what are the salient features of a truss, then each of the member is a two force member. Okay, and then yes, and yeah, so these are in fact I would say the most four important things, or all the points which are required to define or call some structure a truss. Okay, now having said that, and now we know what a two force member is from the previous segment. Now having said that, what can we talk about the members now, and then what do we mean even by the phrase when we say that we will analyze a truss? When we say analyze a truss, what we mean is under these external forces, okay, say F1, F2, etc. What are the forces that exist in all the members? Okay, suppose there are how many members here? 1, 2, 3, 4, 5. So these 5 members, what are the forces which are acting in them? Because these are all two force members. And then why are they two force members? Because any of the bar cannot transfer any twisting moment through the pin joint, which is free to rotate, and that is why all the members must be only two force members. Okay, and one more point why they should be two forces. See, now each of these members, if I suppose this green member, okay, if I bring out from this structure, if I show it here like that, okay, if I show it like here, it is in equilibrium under the structure, but now there are only 2 points of connection with the system, so that I can add in fact here. So any member, there are only 2 points of connection with the structure. Now if there are only 2 points of connection along the structure, in the structure, and no forces or moment is acted on or along the member, that means weight is also neglected, mass neglected. Okay, I mean these are assumptions which are very practical in a way. Okay, as compared to the whole weight that the truss structure actually sustains, mass of each member is completely negligible, and that is how these assumptions are valid to a great practical extent. And now under that condition, when we say that only 2 points are responsible for a member to be connected to the system, there is no way that more type of forces will come. So there are only 2 forces which can come onto this member. Okay, now suppose this is one force F1 and say this is another force F2, and no other moment or any other force there is possibility of coming, because these are the only 2 joints to the total system. Now if there are only 2 forces which can come, then what? It's the requirement, if you remember the previous segment, they must be collinear for that to be in equilibrium. So these kind of forces are impossible to be there, so we can simply say that all the forces can only be in these kind of F and minus F, not like F1 and F2 having any angle between them. So the only possibility that is there is this F and minus F. I mean, the other thing is it could be in the opposite direction also. Okay, so there is another possibility that it will be like this and this, or this and this. Okay, that means either the forces are compressive or the forces are tensile, but they have to act along this line that is the line that connects these 2 points, along which or through which the member is connected to the full structure. Okay, so that's in a way the most important fact about a truss, which will be used to further analyze. Or I was about to say, what do I mean by analyze, right? Analysis means to find out these forces. Okay, every member, suppose here I have, say, member 1, 2, 3, 4 and 5. For each member, those forces, the F1, F2, so like that up to F5, I need to evaluate, because under the applied loading condition, so whatever loads we have applied externally, under that these members will be subjected to some force depending on the configuration, but then they should be safe under that loading condition. What do you mean by that? So that means this force, whether it's compressive or tensile, the member's dimension should be such that it sustains, it is capable of withstanding that force. So that's the idea. So when we say analyze the structure or the truss, we mean that find out all these forces, then we can always figure out whether it is safe for that element or not. Okay, so that is one. Plus these ground reactions. See, ground reactions wherever the truss is connected to the ground, and if you have noticed in the earlier discussion, as a whole the truss is a structure, right, a fixed rigid body. Now when that rigid body is connected to the ground, suppose we consider the full truss like this as a rigid body, and suppose this is connected to the ground say like that, suppose here with rigid connection and here with, say, a roller support, and then the reaction which come from the ground, maximum number of connection which we can solve from the equation of equilibrium is equal to 3, right? 3 unknowns. Because if remember, in the most general conditions of loading in 2D, we said that we can write maximum 3 equations. That means, for example, 2 forces in Fx, Fy and a moment like that. Now if we write 3 equations, maximum write 3 equations, then we can solve for maximum 3 unknowns. So that means in this case it will have, say, Fx, Fy and here, say, Fy prime. So these kind of 3 unknowns if you have, you can actually solve for those. But now if I put, say, another support here like that, okay, then these forces, the extra forces which they have now come into picture, you can't actually solve from the equations of equilibrium. So that is why, so that solvability or unsolvability is termed as, or there is a concept called statical determinant. Sorry. Okay. So if you are able to solve all the unknown forces, okay, that is from the ground and in all the members of the truss, then the system is called statically determinate. Once we go ahead, we will see the conditions under which a system will be statically determinate or statically indeterminate. Okay. Now, so but at this point of time, please note that according to the configurations, according to the number of connections which you put, a system could be statically determinate or statically indeterminate. That means using only the equations of equilibrium, whether you will be able to solve for all the unknowns or you will not be able to. So these are the kinds of questions which we term as analyzing a truss as we go ahead. Okay, so we will stop here and for this segment, and then in the next segment we will discuss about what are the special techniques of analyzing. Now we know what we mean by analyzing the truss. Okay, that means figuring out all the member forces, the ground reactions, and we will see the steps through which you should always move ahead to analyze the trusses. See you in the next segment.